As a global leader in drone innovation and manufacturer, DJI has launched consumer drones with integrated onboard GNSS receiver, including the Phantom 4 RTK, the Matrix 200 series, and the newly released M300, which supports multiple payloads and even solid-state LiDAR, designed to extend its advantages in aerial mapping applications. As a proven, effective, and reliable means of surveying, mapping with DJI drones have become increasingly popular. If you are looking for a cost-effective photogrammetry solution or are currently using a DJI model, I believe today's webinar will be of great benefit for you. As we know that for RTK, the stability and the reliability of the real-time correction data is key. Although the drones have easy access to the correction service network in most reference stations coverage areas, there is always the risk of losing tracking satellites and RTK fixed solutions due to unreliable and unstable network communications. Especially for high precision photogrammetry, this means you possibly have to do resurvey. A local base station correction source can perfectly avoid this concern. In the case, we try to empower the DJI drones by enabling high target receivers as GNSS base. So next, let me introduce our solutions. The communication link is the key to ensuring stable correction data, and DJI leading acoustic technology provide high-speed video streaming up to 3 km, which is better than most micro radio or W-line performance. Therefore, the core of this solution is to relay the correction data from the base station to the remote control via the specially developed GNSS Hub app, which delivers the correction data to the drone. These procedures are working perfectly so far in practice. And from the above figure, you can see the data link map. Okay. For the configuration of this workflow, first we need to configure the base station receiver to connector network mode, which is currently supported by the firmware for the V100 and inno GNSS receiver. And in the future, we may open up more models to ensure our users can use their existing instruments. Okay, for the working flow, firstly, we just set up the base V100 or inno receiver on a lone coordinates points, and then we connect the device using the HighSurvey Road app and configure the data link and the correction type as shown in these slides to the data connector interlight and select the correction type RTCM 3.2. And after finishing that, we can disconnect from the Bluetooth while keeping the base operating. After the base station starts sending correction data via Bluetooth, we simply run the GNSS Hub apps on our smartphone and transmit it to the remote control via our personal Wi-Fi hotspot, which also provides networking capabilities to the remote control so that you can access to the internet. You can log in the DJI account as well as the online data exchange. The GNSS Hub app already have a variety of predefined operation modes built in for the most users to choose from. And for more specialized users, all the parameters like the data link and the correction type could be customized according to the specific needs. And if you have the requirement to have a trail, and you may download this app from our official website or ask it from your sales or technical contact. Okay. After completing the above steps, you can go to the DJI GNSS RTK app and log in with the entry parameters as shown in this figure. And the above figure is the default settings, and you can change it as you want to in your real projects. Congratulations. If you see this screen on your smartphone, I'm sure that all the settings were successful and you are ready to fly. This configuration process is slightly complicated at the moment, mainly due to the limitations of the DJI, because they blocking the communicating protocol, and the remote control communication module is not support the current mode. So I think the workflow will be gradually simplified as it evolves, and our developer and engineers are working on it. And also any feedback after use would be appreciated if you could send it to us. Okay, this is just a brief introduction about our solution for the RTK part. With the app GNSS Hub and the V100 or inno receivers, you can easily configure it as a local correction source to your DJI flight. Currently, this solution have support the Phantom 4 RTK and Retrace 200 series, and in the near future we will also add the capability to support the M300. Okay, next let's go to the PPK part. I think this part should be highlighted because many customers has come to me and ask what is the PPK and what's the difference between the PPK process and the RTK. And after that, I may give you a live demonstration so that you can have a further understanding of its workflow and to understand how convenient it brings you for your DJI flights. Okay. As I mentioned that many users have asked me why I would highly recommend much older technology like PPK when RTK is already enabled on DJI drones. I told them because compared to the RTK, the PPK is much more reliable, especially for topographic surveys with higher accuracy requirements. Because you know, for the high precision topographic map, the accuracy and it is very important, and the PPK could ensure a very stable and reliable precise result to make sure the accuracy and the final deliverables is well to deliver. And okay, and RTK for some weather conditions such as good GNSS environment and if there is a reference station coverage, I think RTK is still a choice because it is much easy, not need for the post-processing and much easy to access too. So, but most of cases, I think it is not a working condition, so that PPK could give us more confidence in our field works. And also because of the difference in the series, the PPK could support a longer baseline compared to the RTK. So that's the reason why I always recommend our UAV users or customers to have a trial with the PPK and to verify the difference between the RTK process and the PPK process. Okay. PPK Go software features more advanced algorithms than the the well-known open source RTK Lab. It provides enhanced support for the Beidou constellation, and it could automatically select the constellation and the frequencies, make it a combination for a faster data processing and a better data quality. Also, it is easy to overwrite the precise high-precision geolocation information to the EXIF attributes of the images so that the user can load them directly in the 3D processing software. Next, let me show the detailed workflow with a real project, so you guys may have a better experience of the whole process. Okay, let me just run the software first. Here I have prepared a project connected by our team in July, and I may use this project as a materials to perform a complete PPK processing. If we open the DJI raw data, we may check that there includes the imageries, and also in the end of the folders, you may check the raw observations data as well as the time steps in this folder. And next, let's open the PPK Go software and create a new project first. Okay. After that, we can select the pace of the raw project. Okay, it is here. Just select the main folder of the project of the DJI folders. And the software will automatically match the raw observation as well as the time steps in this folder. If you can see the pace here, that means the files are successfully loaded. And after that, you can select the raw observation data from the base station. And in this project, we connected the data with inno GNSS base. Just select the relics format or the high target GNSS format. Both is okay. Here, I just select the relics format. And also, this means that the users could use their existing receivers as base. No matter it is high target brand or other brands, it is quite flexible and convenient for our users. And here you can also check a button named Automatch. We have successfully integrated several reference station source. For example, in Japan, we have integrated the Japan course network so that our user can easily access the national course or any commercial course provider and can download the raw data of the base station from the course. That means the user cannot use their own base, but download it from FTP server or other source. It is very good for such kinds of requirements. Okay, then press OK. The software will finish the loading. Depending on the size of the project, it may cost a few minutes to check if all the file is complete and if there is any problems of the raw data. Okay, and next, you can define the coordinate system and projections as you want. As you can see here in this interface, it is the same module that was used in the HGO software, also the Highway. That means you can just note the DAM file you created in your field work or from the Highway Road apps. Here you can select the predefined correlation system in the software folder. Here I just use the okay this version. Here I just use that of China. It should be okay. And after also the grid file could be loaded here to get a better accuracy of the elevation. Here I just use the parameters of our project. So after finishing that, we can click OK to confirm the configuration. And here you can see the software will display the trajectory of the drones in the screen, so that you can have a look at your flat to check if anything is okay. And also here you can check the marks of the photos to confirm if any photos is missing or not. And if you have access to the Google Maps, you can also check you can also overlay this trajectory on the Google map to check if the flight zone is okay. And after that, we can input the lone coordinates of the base station here. This values is loaded from the fire head of the relics files. But normally we should manually input lone coordinates or coordinates of the coordinates of the control points here to ensure a better accuracy. Here I just use the node from the Renix fire height and press save. And for the antenna parameters, the modules could read from the Renix firehead also. Here you can see it reads the receiver type is inno. If you are using other brand of receivers, you can change the settings to by receiver type and select from this list. This list will be kept up to date with the NGS organizations. So always you can find the correct modules of your base. And if you don't know the detailed information of the antenna parameters, you can also input a measured correction here manually and press save. Okay. And after that, we can check the settings of the drones. Because for the DJI drones, the manufacturer has already write the correction information such as the altitude of the gimbals in the timestamps files. So there is no need for our users to do any offset correction here. You just press save is okay. The software will read from the DJI log automatically, so that you can ignore this part. But if you are using other brand of drones, you may need to manually import such kinds of offset. Otherwise, the final result of the process would be effect less or more. Okay. Here we select DJI and then press save. And to this step, we have finished all the configuration of the process. After that, just press the process button to start the calculation. On this progress window, you can check the status of the calculation and also the information of the satellites. Normally, it just takes a few seconds to finish the whole project. That's depending on the size of your flight mission. If you have taken a lot of photos, it may take it may take longer times. And here you can see the changes. After the PPK processing, all the route, the trajectory has become green color. That means we got 100% of the flag rate. And here you can check the different color indicate different kinds of solution status. As my experience, for most of the flight mission with a DJI drones, we can nearly get 100% of flight rate. Okay. After that, we can export the precise information to the imagery. Press the export button here, and the software provides three kinds of exchange format. The first one is a text format of report, so that it could be logged in the Pix40 mappers. Here I just Pix40 mappers. Okay, save. Okay, and here you can check this file with the Notepad++, and here you can see the software has written these attributes to the text file, such as the picture's name, the longitude and the latitude of each pictures, also the elevation, so that in the Pix40 or Matship or other such kinds of softwares, we can load this report directly to the software and match with the photos. But I think in practice, this is not the most convenient way for our users. But for some expertized users, they may want to customize their own format for some not so popular software. So we just leave this for them. And I recommend our users to select this way of exporting, to geotag the precise coordinates to the software EXIF attributes. Just select this one and press save. Okay, and if you select this way, the PPK Go software will make a copy of the raw photos and then overwrite the precise coordinates, the precise geolocation in the EXIF attributes, and later you can check it is different. And in this way, the users could just node the photo site in the 3D survey and modeling software. I think this is much flexible and flexible ways. Yeah. With the processing, I can just open the folders. I can just open the PPK folders here. You can check the software generates new folders to store the processed picture here. Okay. It may take a few time because the software will copy the files and write to the attributes. It takes times. Okay, it's finished. And after that, we can open the folder to check the pictures, the processed pictures. And in that folder, I just open the raw data. This is the raw data. So we can check the difference between the raw data and the processed pictures. Let me use EXF tools to do that. Okay. For example, we take the first picture 0001 for example. Okay. Here you can check the rough location of the raw picture is this. It is 59458. And if I open the processed picture here, you can check the geolocation has been updated to a fixed solution coordinates. So in this way, you can just note this precise photo site to the 3D mapping software and then precise. Okay, I think okay, let me back to my presentation first. Okay, I think the whole workflow is very easy to use and compared to the open source solutions like RTK Lab, PPK Go software provide a streamlined workflow and also much smart algorithms to fully fit our users' needs. So I recommend you to have a trial of this software and compare it with the current tools you are using. And after that, you may have your own experience. Okay. We also have done a few projects here near our office to check how the PPK process works. For the furlough performance compared with the RTK. And here I just show you the recent project we have done in our working room. Here is the economy park, which our headquarters are located in. We select this area as large as 0.4 square kilometers to do validation flights. We select using Phantom 4 RTK and inno 1 GNSS Receiver as the base, and we configure our flight mission as shown on this slide. The flight altitude is 100 meters to avoid some optical high buildings here in this park, and we set the ground sampling distance as 3.9 centimeters, and the over and slight live is 80% and 70%. Normally, you can set it both 70%. It is fine for this kind of mapping. And here in this slide, as I just showed that the PPK Go software could complete the PPK processing first and then overwrite the precise geolocation to replace the raw geolocation that is not accurate. So it is very, very good, I think. Okay, and after completing the project, we have used the Pix4D mapper to finish 3D modeling. We have the software have generated the digital OS model, also the digital surface model, and after that we load these 3D models generated by the Pix4D mapper in QGIS software and query the the P1 to P8, totally 8 checkpoints, and compare them with their known coordinates to get the RMS statistics. The final results shows that both are comparable in terms of the horizontal accuracy. Here you can check in the above charts. But for the elevations, for the elevations, PPK processing performs better than the RTK. This may be related to some kinds of flaw in DJI onboard RTK algorithm, which has not been resolved so far. And the above result is with RTK also at 100% fixed. So you can imagine if how bad it will get if the corrections is affected in the mission. In short, I think PPK processing appears to be more reliable, both in the theory, also in practice. Okay. The PPK Go software now is currently available in most regions. So if you are interested in this solution or have any questions or expect to establish a partnership, please don't be hesitant to connect me at 7zhao@hightargetgroup.com. Okay. Okay, that's all. Thank you again for your time, and let me pass the stage to my coworker Aiden, and he will introduce you the latest status of high-target GNSS algorithm augmentation service development. I think most of you guys are very curious about the status of high-RTK system and when it will be available globally. So please feel free to